Today, I'm speaking with Alison Young. Alison is an award-winning investigative journalist and a professor at the University of Missouri School of Journalism who's been uncovering lab leaks and accidents at prestigious U.S. labs for over 15 years.
The case of the found smallpox vials.
So around the same time, the CDC was having all kinds of incidents in 2014. In the middle of all of that, there was a cold storage room on the campus of the National Institutes of Health, just north of Washington, D.C., where they were moving around some old cardboard boxes, and they look inside and they see all of these little tiny, very fragile vials from decades ago that are labeled in typewriter print with various pathogens' names on them. And it's powdered material. And as they're going through these glass vials, they see some that are labeled as variola.
Which, just to be totally clear, is smallpox.
Exactly.
Variola is the pathogen that causes smallpox. Okay, so go on. They found vials of smallpox in a box in a storage room.
Exactly, in an unlocked storage room. And so this should have been incredibly concerning because smallpox is incredibly deadly. It has been eradicated from the planet. And smallpox virus is only supposed to be found under treaties in 2 labs in the world. One is in Russia, and the other is a specific lab on the campus at the Centers for Disease Control and Prevention in Atlanta. And so these vials shouldn't have been in this cold storage room at NIH. What was also concerning was how they responded to it when they found these vials. Ultimately, it was one scientist by themselves who basically picked up the cardboard box and walked it down the corridors of this building at the NIH and across the street and into another building. All the while, they're hearing this clink, clink, clink of these fragile old vials hitting each other as they're walking along. The FBI report that I read of the incident criticized the scientist and just the whole handling of this box because when it was properly cataloged in the end, there was a vial that had broken inside this box. And once again, the world got lucky. And it was not smallpox virus. It was some sort of a tissue sample. But as the FBI report noted, that had that been the freeze-dried smallpox specimen, there was nothing really protecting the person who was carrying it.
It's so disturbing. And so many things went wrong there. There was the fact that the vials were left there in the first place. There was the fact that the people transporting them didn't use the right PPE, that they didn't treat them with caution.
And there were also the biosecurity aspects of this. You know, you would hope that everyone who is working around really very dangerous pathogens like smallpox, which should not get into other people's hands, part of the concern that was raised is you shouldn't necessarily have one single person by themselves carrying a box that contains smallpox virus.
Yep. And that's because, it's one of the few pathogens that a single person could use to use as a bioweapon, basically.
Correct.
The Soviet anthrax leak.
In this particular incident, there was an accident at a lab that was believed to actually be a bioweapons facility by U.S. intelligence, but a lab nonetheless that was working with large quantities of anthrax. And it appears that it spewed a giant plume of anthrax spores over a town, and people downwind were sickened, animals were killed. About 60 people in that case died. Initially, the authorities sought to claim that there was no airborne anthrax, that this was ultimately a result of anthrax food poisoning, possibly from black market meat or some sort of contaminated cattle feed or agricultural feed. And that was sort of where it was. And over time, because it was such a huge and deadly outbreak, there was intense scientific community interest. And eventually, there was a group of scientists who invited officials from these former Soviet communities to come to the United States and give a presentation at the U.S. National Academies of Sciences. And there they produced all kinds of slides and charts and told compelling stories of racing up into the mountains and how they were there to help save these people. And they showed all kinds of information that really was making the case that this was a foodborne anthrax outbreak. And coming out of that meeting, there are news clippings in the Washington Post and the New York Times and elsewhere where prominent U.S. scientists say, they've been incredibly transparent and they've made quite the case. It looks like this really was gastrointestinal anthrax and not, some sort of an airborne release. And then it took many more years until 1992 when then Russian President Boris Yeltsin came out and made this sort of very surprising statement in a Russian newspaper that, in fact, that outbreak was the result of a military lab accident.
Yeah, so this case absolutely shocks me. I mean, one, it's just horrific. 60 people died. Two, as you said, there's this extremely successful cover-up by the Soviets, which I guess was particularly because they were violating the Biological Weapons Convention and wanted to hide that. And then three, just bizarrely, Boris Yeltsin later, unprompted, admitted that this was caused by military bioweapons research. But yeah, I wanted to talk about what happened after all of that, which was this joint effort by American and Russian scientists to find out exactly what happened. I just found this extremely moving. Can you explain what they did?
Yeah, it's fascinating. So, I mean, here were these Russian scientists who, at the time all of this occurred, were incredibly brave and basically hid away evidence to keep the KGB from taking it away. And so they hid away their notes. They had samples from the people who died, and they kept them in jars, but they put them out in the open, almost hiding them in plain sight so that they wouldn't be confiscated.
Wow.
And they had kept these for all of these years. And so as the political situation changed in Russia, it became possible for them to actually disclose that they had this information. And they did some remarkable investigations where they even went and looked at other records that weren't destroyed, such as who got compensated. They went to graveyards and looked at the death records. And ultimately, even some of the main U.S. scientists who were the biggest proponents that this was not some sort of a bioweapons lab and that it was absolutely what the Soviet officials had said. They were absolutely believing of this initial cover story that this was a meat problem. Those same scientists ultimately came around, and some of them assisting with the Russians' research, that no, this was a huge anthrax plume, and there was plenty of documentation for it. And I think the thing that is so instructive is it took 15 years to get to that point from when the accident happened and all of the years of cover-up and all of the years of international scientists, many of them believing the cover story, to ultimately getting to the truth.
A culture of martyrdom.
One of the challenges is the idea of establishing safety culture within organizations. Part of my book goes way back into the history of biological safety. And I spent a lot of time reading the papers of a man by the name of Dr. Arnold Wiedem, who is considered the father of modern biosafety. And part of the reason the book goes into depth about Arnold Wiedem's findings is that I think many of his concerns about the lack of safety culture in microbiology, the difficulty in getting certain scientists to accept the importance of following safety protocols. Some of his resistance to safety culture that he saw way back in the 1950s are some of the same kinds of things that play out today in these incidents. Arnold Weedham talked quite a lot about this idea of being a martyr to science. Obviously, the people who went into microbiology over time are people who are very dedicated to the study of science, to trying to improve the lives of people around the planet. And one of the things that's important to remember is that microbiology is relatively a new science. It's a young science compared to chemistry and radiological sciences. And what Dr. Weedham said is that those scientists seem to be much more open to the scrutiny of their practices than those working in microbiology labs, who, for much of the history of microbiology, because there were not ways to keep them safe, were often catching their experiments. And Dr. Weedham also talked about how, again, this is back many years ago, that some of these scientists took great pride in how many times they had become infected because they were doing this for the greater good.
Yeah. I remember that. I remember finding it striking in the book, reading about these cases where scientists working before a bunch of better safety practices would basically, as you said, brag, like, I've gotten TB 4 times already. And it was almost a battle scar that they wore with pride. Yeah. And so maybe there the takeaway is this field is coming from this kind of like initial foundation of getting these diseases is a norm and is even like kind of a good thing. It's like a badge of honor. And so when you try to throw all these safety practices on top, they're resistant because they're like used to this. They don't regard it as like a terrible thing. And that's part of what's made making safety a norm a much harder problem. Does that kind of sound right?
Some of that, I think, is very much the case. And also, there's just not a culture of tracking these kinds of infections. There never has been a culture of that. I mean, to this day, there are no universal tracking systems for these kinds of illnesses in labs or accidents. And I think part of the challenge as well is nobody likes having to do things that make it harder to do your job.
Sure.
And one of the realities of the kinds of safety procedures and equipment that are required, depending on the pathogen, they can make doing your work slower and more cumbersome. It can be more expensive. There may be limited access to certain kinds of equipment. All of those kinds of things, at least over time, and what Dr. Weedham wrote about, created a culture where there was questions about whether any of it was necessary. And that's where the culture, that idea of the martyr to science culture comes from. One of the challenges is, okay, so that was back in the 50s, 60s, and 70s when Dr. Weedham was really writing about those kinds of things, and here we are in 2023. What is the culture inside individual labs? And it's hard to say, but you can see in the incident after incident that there are individuals and institutions that are not paying the attention to safety that they should be.
No one wants to regulate biolabs.
This is a topic I've been now covering for 15 years. And it's important to know that going back at least 10 years ago, the U.S. Government Accountability Office, they started issuing reports raising concern that as more of these kinds of biological research facilities are built and doing more experiments with more risky pathogens, there is this increase in the aggregate risk of a catastrophic accident. And back then, okay, so I've been covering hearings in Congress going back over time. There was not one political party or another that was interested in this. This was a bipartisan concern. And as I wrote Pandora's Gamble, it was a huge reminder as I went back and read through some of the transcripts of hearings that I'd sent in as a reporter and seeing both Democrats and Republicans asking really important questions about the policy issues of how do we deal with the safety of these labs. There was a recognition of the importance of conducting biological research. I mean, we all need this. I mean, I don't want lost in any of this the idea that this world has benefited greatly from the COVID-19 vaccines and from all kinds of work that these labs do. But we also need that work to be done safely. And how many labs do we actually need? And Congress was holding hearings and looking at this stuff closely. There were pushes in the 2014, 2015 timeframe when I was writing about a bunch of accidents at the Centers for Disease Control and Prevention and at Dugway, as we've discussed. There were even more hearings raising questions. Did there need to be a single federal entity that was overseeing lab safety? And then it went nowhere. And that has played out over and over the years. And part of it is that the organizations that operate labs, nobody wants more regulation on them. Nobody wants more scrutiny. Nobody wants more red tape. And the federal agencies that Congress and the public relies on to advise on what do we need to do in these arenas, they all have potential conflicts of interest. I mean, the agencies like the National Institutes of Health, it's one of the largest funders of biomedical research in the world. They conduct their own research. They are funding the research often at the labs that are having the accidents that are of concern. You have the Centers for Disease Control and Prevention. They are one of the two primary regulators in the limited subset of these labs that are actually subject to any regulation on safety. The CDC's lab have their own series of issues with safety problems in their labs. So it is something that every few years, at least in my coverage of it, you see interest in Congress and then it dies back down again. And now with COVID-19, obviously this is back in Congress and being discussed again, but the whole political climate in Washington has become so toxic that is now adding a new layer to the whole debate.
Nobody is tracking how many biosafety level 3 labs there are.
One of the things that just is so frustrating in this arena is nobody is even tracking how many of these labs there are. One of the biggest surprises for me when I started covering this is the U.S. Government Accountability Office, which is the nonpartisan investigative arm of Congress. They produced reports going back more than a decade ago that said even the U.S. government doesn't know how many biosafety level 3 labs there are. And part of the issue here is that it is such a fragmented area. If you are a privately funded lab and you're not taking government money and you are not working with a select agent pathogen, the government may not really know that you exist as a lab. They may know piecemeal, like you might have to, have workers' compensation, or you might have to have some OSHA things, or you might have to have a wastewater permit, but you don't have a lab permit. And so there's no chronicling of where all these labs are. And so one of the things we did when I was a reporter on USA Today's National Investigative Team is we set out to find out how many biosafety level 3 labs can we even identify? And it was incredibly difficult. And we identified a couple hundred of these labs across the country, but what it took to do that is literally Googling like biosafety level 3 lab, and then we could find where places advertised it. Or we looked at government grant records where they mentioned that they were using a biosafety level 3 lab or a BSL-3 lab. Or we looked at LinkedIn and looked where people promoted the fact that they'd worked in these labs. But this is cobbling it together from an incredible number of records that it's something that you would think that the government would know. And that's just in the United States. What I have a Google alert that is set up for BSL-3 and BSL-4 labs. And so I see the press releases that go out that Google crawls when various countries are announcing or various universities are announcing that they're building a BSL-3 or a BSL-4 lab. But there is no one place that policymakers or the public can go to see where these labs are or how many there are.
How can we not be tracking those?
There just is no mechanism. There's a case right now that has gotten some recent attention out in California where there was a biotechnology lab in Reedley, California, that has gotten some attention because literally a code enforcement officer in this small city discovered that there was this lab and they had 1,000 mice and they had negative 80-degree freezers out there. They had all sorts of biological materials. And ultimately, and I've been working on some reporting in this area, what the local officials have said is that the only way they were able to address this lab, because it was privately funded, it didn't receive any government grant money, and they weren't obviously working with any select agent pathogens, they had to cobble together and use like local code enforcement and other sort of piecemeal regulations in order to address the facility. There was no lab authority to go to address the biohazards of the facility. And it's the thing, this issue has come up over and over the years, but it's not one that policymakers have so far addressed. There has been a lot of talk, and it has been known for a long time that there are gaping holes in the oversight because of the fragmented nature of how we look at these biolabs. There's one other aspect of the proposed legislation that is worth pointing out. It does include a provision that asks for a biosecurity board in the U.S. government to evaluate the effectiveness of the current federal select agent program in overseeing bio risks in this country. And it asks for proposals to, in its words, harmonize the various fragmented pieces, whether it's at the NIH guidelines, the select agent program, and the recommendations in something called it goes by the BMBL, but it's basically the biosafety manual. It's recommendations, but not regulations of safety practices. But what's interesting, again, in how it is written is it sounds like harmonizing, but leaving in place the fragmented system of multiple agencies being responsible for this kind of work.